Okay, so this week's lesson is going to be about how to name branched chain hydrocarbons, and we are only going to do alkanes. So there will only ever be single bonds. We're not going to deal with any double bonds or triple bonds. There's a way to put names in for those, but you guys can learn that in college because we're not going to do it. So our uh, straight chain alkanes were fairly straightforward. You just had to count the number of carbons there were and give it that name. Well, now I've got stuff hanging off all sides of this and all over the place, and I need to figure out what name this is going to have, and does it matter where it's attached, and does it matter like um how big this thing is, exactly what's going on, and the answer is all of it matters. So this can be a really daunting process. So what I'm going to do this week is I'm going to put all the directions in the classroom as notes, but the videos each day is just going to give you a piece of it, and the quiz and the practice worksheet stuff are just going to involve a one piece of the puzzle, and then by the end of the week we'll have all the pieces put together. So today what we're going to talk about are called parent chains. The first process in naming any branched chain hydrocarbon is to find the parent chain. The parent chain is the longest chain that is in the molecule. And it's tricky to find sometimes because the parent chain here is not 5 carbons long. That is not the longest chain of carbons that you could possibly have. So you have to find the longest string of carbons all put together, but remembering that this whole thing is like floppy and bends, and you could just pile it up and you can stretch it out and lay it wherever you want. So what you have to do is find absolutely the longest string of carbon that you can, which should, if I'm not mistaken, run here. Okay, now could I have run it up here and there? Yes, it doesn't matter. If it's the same distance either way, it isn't going to make a difference. But I don't want to run it this way because this one would have gone out one more than that one. So the longest chain here is 1, 2, 3, 4, 5, 6, 7 carbons long. So the parent chain for this molecule right here is heptane. Because it is 7 carbons and they're all single bonds. Okay, and then the other process that I want you to do today is to number the carbons on that parent chain, and we number from the end closest to what we call substituents. That means the extra pieces coming off. Okay, and you want the end that is closest to a substituent. If it's a tie, you go at the end closest to the most substituents, and if that's still a tie, you go at the end closest to the biggest substituent, and frankly, if that's still a tie, it probably doesn't matter and it's symmetrical. So in this molecule, if we started numbering from this end, we would go 1, 2, and our first substituent is on the third one. And if we start from this end, we go 1, and our first substituent is on the second carbon. So we want to start from this end. And all we're going to do today is go through and literally right next to these carbon atoms, numbers 4, 5, 6, 7. And then the quiz will ask things like what number carbon has the first substituent on it. Okay, and for here, this is heptane. The first substituent is on the second carbon. Okay, and that's all we're going to look at today. So I'm going to try one more with you, and then we leave some problems in a Google form. So let's see as we make this up. One here and there, and here and here and there. Let's put one here, one there, and how about one here? Oh, one there and one there. Okay. So step 1, our parent chain, longest chain of carbons you can find, should run up and through there. And we count 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is nonane. And then we're going to number them from this end. First one is on the 2, on this end, first one's on the 3. So you would go 1, 2, 3, 4, 5, 6, 7, 8, 9. That's all. Why do I bounce back and forth? Because there's things in the way. Okay. So that's all I got for today. Tomorrow we'll look at then how we name the substituents and how we give each of those a name.